had a good break over the holidays, and you're back. It's a new year, and we're going to look at what functions are. So I'm just going to give you today a very brief introduction to functions. So functions relates one set to another. That's the function, and that's the set. And a set can be made up of numbers, letters, or words. So let's say we have that. Would that be a set? You've had sets before, yeah? Would that be a set? Okay. And how about nuts? Could that be a set?
Yes.
Now, if you remember, when we did sets, we used these little things. What were these?
Brackets.
Okay. And if I put, let's say, the numbers into brackets, and then what do I need to do?
Commas.
Commas. Good. That is a set of numbers. Okay? And we can also do as a set of letters. And the last one, example that I had was dogs, cats, and rabbits. So that could be a set of words. Okay? There are two different types of sets, and see if you can remember these numbers. These words. Does anybody remember this word? Finite and infinite. Okay, so let's look at what these mean. You should know this. Okay, how about this? And you know what ellipses are? That means there's something in between. What might this be?
Finite set of letters from the alphabet.
Okay, and why is it finite set?
This has a start and end.
Okay, great. How about this? Let's get a little tricky here. What's that?
Infinite set of numbers
Okay.
and whole numbers.
Because,
Well, the dots are on the end, so it means it just keeps on going forever.
okay, so these sets we've defined as a finite set here, infinite set here, which is also represented by or a finite set, which only has 26 letters in it at most. Is everybody with me? Okay. Now, we were talking about the word function, and basically, I think of a function as being a machine. So I have a machine, it's a function machine, and I'm going to put some potatoes in it. Delicious potatoes. And that's my input. I put potatoes in the machine does something, and I get chips. I get the curly chips because I like the curly chips nice and brown with lots of salt. So that's what a function is. It's like a machine. You put something into it, input, and you get something out of it. So let's take that a little bit further. So let's say this is my input set. We already know that word set. We're okay with that, yeah? So we're going to put the word input set in there. And then what comes out, like the cream of chips, is an output set. Everybody with me so far? Now we can also do something called a function table. It has an input This can also be called the domain and the range. And I'll keep using those words so that we become familiar with the words, if that's okay with you. So, if I have a function, I can name it. I can name it with words, or I can name it with an equation or something. And let's say I call this number of sides. And for my input, I'm going to put a triangle, a square, and an octagon. So, we know what a triangle is, don't we? Okay? We know what that looks like. Yeah? Looks kind of like this. So what do you think we have as an output on a number of sides? A triangle would have
3,
3. Okay. And a square?
4,
And how about an octagon?
8.
Okay. We're really good at this, aren't we? So far, so good. Now, let's look at something just a little bit different. And let's look at an equation. We're going to have an input and an output. Output. Sorry about my handwriting. So, if I have an input of 1, how do we work that out?
Sub 1 where the x is.
Okay.
Put 1 where the x is.
Okay, right. So y equals 2 times 1, which is
2.
2. Okay, let's say the input is 2.
4.
Put 2 where the x is, just like you said, equals 2 times 2, which is 4. And if we had another example, let's just keep it simple. Y equals 3, 2 times 3, which is 6. So I want you to notice that all of these have exactly one output. Now let's get a bit tricky, okay? Going to get a little bit tricky here. We have an input, an output, or a domain and a range. And let's use the equation y squared equals x. Now what do we have to do to this equation to use it here? Where we have x as the input and y as the output. Okay, you guys remember this? We need to make that into a y. So everybody remember this? And that equals, well, what's missing here?
Plus and minus.
Plus and minus, exactly. So we end up with y equals plus and minus square root of x. So let's put some numbers in here. Let's make x equal 9. Now, what can we get for y? If x equals 9, we can get 2 numbers. One is positive and the other one is negative. So that would be turned into a positive 3 or a negative 3. Great. What if we do 4? Y equals plus or minus square root of 4. We get 2 numbers. What numbers?
Minus 2.
Plus 2 and a minus 2. Can you see the bit of difference here? This one has more than one answer. Multiple answers. This one has multiple answers. But the fact is, there's a great rule that says for a function, each value, input value, has only one output value. So, if that's the case, would this be a function? Each value has only one output value. Each input value One output value, yes. Would this be a function?
Yes.
One output value, great. Would this be a function? No, so that's not a function. Let's have a look at something called mapping, and it's really easy. Let's just do these here. So if I have, it's called mapping, and if I input 1 into this function, I get a 2. If I put 2 into this function, I get a 4. And if I put 3 into this function, I get a 6. That looks pretty good. You can see how it's 1 on 1. Let's look at this function. And the way you can say it is 9 maps to positive 3 and negative 3. And 4 maps to positive 2 and negative 2. So, of those two, which is a function and which is not a function?
The one on the left. It's fine.
Okay. One on the left. Okay, got my rights and lefts. Okay. That's a function. And that's not a function because it has more than one output. Now, we're going to look at something really quickly. We're almost done here. Don't fall asleep on me yet. Who remembers what this is? Let's jog our memories a bit. What is that?
Cartesian plane.
Okay. And what can we do with it?
Draw graphs.
We can
Draw graphs.
Yeah, we can plot points on it. That's great. And what are these things?
Axes.
Okay. And which axis is this? This one here.
X.
Okay. And this one here would be a
Why?
Y. Good stuff. Now, there's a really simple method. I call it the chopstick method of how you can tell whether or not something is a function. So let's have a look at that. Now, there's two words, horizontal and vertical. Vertical. Yes. Now, which one of these is horizontal? That way, X. And vertical would be the Y. Okay. And it's called the vertical line test. So I'll write that down because this is going to be part of your homework, right? Okay. Let's go back and revisit y equals 2x. And it looks something like this. Now what you need to do is I have chopsticks in my bag, but we can pretend this is a chopstick. And when you do the vertical line test, we take a vertical line and we move it across the graph. And you can only cross this line one time if it is a function. So we move it across the graph. What do you think? How many times does it cross there?
1.
And there.
1.
And there. 1. Okay, so would that be a function?
Yep.
Yes.
Okay, let's look at a different, slightly different example. Very different example. Okay. I'm going to leave vertical and horizontal up there, so let's look at something that looks like this. That's a y squared equals x. Now we're here. What's happening? Anything? Are we good? Are we good? We're good? We still good? What about here? We good? 1 point, yeah? What happens when we get here? 2. And here? Okay, so you only have to find one instance, but you can see here that that was proven not a function because of the way we mapped it out. And here you can just just use the vertical line test, which is a really easy way. Now here's two that you know very well. They'll be quick. What about, you'll do this neater than me and put the x's and y's on. What about this? What's that called?
Parabola.
Excellent. Good stuff. So as we go across here, is that how Australians pronounce it, parabola?
Depends who you talk to.
What do you think? Does it go through more than twice? Do you see any place? I don't. Yay! So what is this? Is this a function, or is this not a function?
The function.
Good. Okay. And one last quick one is, how about this one? Certainly we all remember this one. What's that?
Not a function. Oh, circle.
It's a circle. Good. And why is it a function? Is it a function? Look at that. That's not one. What happens? We go across. So see how simple that is? If you back something out, graph something out, you can actually just visually see whether it's not a function or it's not a function. Okay, I just want to show you a way of writing functions really quickly. Okay, you'll see a lot of functions written like this. It can be f of x equal y, it can be g of x, h of x, f of t. But this is the way you'll see it the most. And what does this mean?
They're the same.
They're the same on either side. So that's equality, right? So because we can do this, we can say back to y equals 2x. What can we substitute here?
F of x.
F of x. And that's how I say it. I say f of x equals. But some people say a function of x equals y. I think there's a big mouthful. So that's that one. Do this one for me really quickly. How would I rewrite that?
If x equals 2x plus 1.
Okay. And we'll just do one more. How would you rewrite that?
F of x equals x plus 1.
Okay. Now for homework, what I want you to do is find two examples of a graph. One that's a function and one that's not a function. I want you to be able to come up and show everybody how you proved it was using either the vertical line method or the mapping method. Okay? And that's for your homework. And next week we'll get even better, further into